Can you guys hear me at the back? Is it working? All right, so it's super exciting to be here. How many of you love SQL Server? Yeah? All right, how many of you love the fact that SQL Server is coming to Linux? A few? All right. How many? You know, it's always fun when you have like a big stage and most of it's covered by it's interesting to see how to work this, but how many of you have used Azure SQL Database? Great. It's very, very exciting to be here and talk about, how do you build global scale relational applications using Azure SQL Database. So just before we get started, the keynote the session is divided into two parts. In the first part, we're very fortunate to have two of our most important customers, actually, ASOS and DocuSign, customers of Azure SQL Database, who are going to talk about their own story, their own journey, as they're going about transforming their business. And it's interesting, each of them has a unique perspective. With ASOS, they leverage the opportunity of moving to the cloud as a way to completely rewrite their application, right? So they, following the cloud model, et cetera. And we're going to have Bob, the CTO of ASOS, come and talk about that. And then with DocuSign, they'd already perfected the art of building a highly scalable application on-prem by leveraging the best performance of the hardware that they could get using SQL Server, various versions all the way to 2016. And they had certain requirements in terms of not being able to change their applications too much, as they sort of looked at global expansion. So we'll hear from both of them, because I think that's a great way to learn as each of you go through your journeys what to sort of expect. And finally, I'm going to have Perry on stage with me to build sort of a global scale IoT app, a connected car app based on what Koros, who's one of the customers of Azure SQL Database. So this is a real application that's been designed by them to create rich immersive experiences for their customers. So they talk about not just building a car, but a whole life experience around it. And finally, we're going to share all the code for the application. It's all available on GitHub. All right, so let's get started. First things first, building global scale applications is not easy, right? The first thing is, the expectation is around rich experiences is wherever you are, right? If it's an application that sort of spans, it's global scale, so wherever you are, the response times, the experience of the app shouldn't have to depend on your location. That's very, very critical. The needs of the application, right, in terms of what the load on the application would be at any point in time, has to be accommodated, right? So the application shouldn't always be provisioned for the peak, because then it becomes very expensive. That's one thing. Predictably managing the costs of the application. While the cloud model is great, one of the big things that we hear from ISVs and SaaS application developers is that it's very hard to figure out what my margin is going to be. In the on-prem world, when you sort of knew exactly what the SQL license costs you, you could very predictably look at your business model, because the customers sort of paid for the SQL license themselves. Right now in the cloud, when you're sort of transforming your app and you're building it, you sort of have to accommodate all of that. So your consumers who are using your application essentially now are going to depend on the predictability coming from a cost standpoint. And how does the platform guarantee that? Finally, there's lots and lots of new languages that are coming up. For data scientists, now you have R and Python, they're becoming a big deal. A lot of you are .NET developers. We have customers who use Java, Node, PHP, Python, all the ORMs that are built around it. And so there's just a lot of expectations on all these languages working against the platform. And finally, since the data is being stored in the cloud, security and compliance become very paramount, right? Every customer, we sort of talk to, every SaaS ISV that we speak to essentially has this concern. Like, look, it's great, I buy into the model, but my customers are coming and asking me, is your data secure? Like, what does it mean to put your data in the cloud? Now, with Azure SQL Database, we have an intelligent database service that is attempting to solve all these challenges for application developers. Right? That's our promise. We've really looked at the challenges and said, how are we going to go address that? The first thing is we've built a database platform that essentially actively learns from your application. So like today, we get about 700 terabytes of telemetry data every day worldwide. We have about 2 million active databases that are using SQL Azure, right? And based on that data, we've created machine learning models that essentially track every query and that's run against every database to see if that's regressing. And if that regression happened because of something that we changed in the back end or a change that happened within the application itself. And the accuracy with which we are able to predict the change that causes a regression is significantly increasing, right? This is a great benefit. So the meme with which we live is your app needs to get better the more you use the platform. Scale with zero downtime. I mean, this is almost table stakes, right? As you sort of look into provisioning your apps globally and sort of increasing the amount of resources that you want to give in a specific region, that needs to happen without your app ever going down. But this is the foundation. Now, all the features that you've come to love in SQL Server, in-memory OLTP, which gives you 30x improvement on your transaction performance, or column store, which sort of, in some cases, we've seen 100x gains in the performance of analytic queries, or HTAP, where you're able to create an updatable non-clustered column store index on your in-memory OLTP table or your regular row store table, right, to sort of do real-time analysis. All those features are available. So you get scale up and scale down without any downtime and all the great benefits of SQL Server. We have introduced this notion of elastic pools, which helps you save costs. This is the idea where across all your tenants, if you're building a SaaS app, you can pool all the databases that capture the data of each of these tenants and provision an aggregate throughput that you want to give to that set of customers, right? So it's not being where you're provisioning at peak performance for every customer, which becomes very expensive. So the whole notion of elastic pools is great when it comes to sort of saving costs. Adapts to what you're used to in terms of tooling and languages. Of course, we'll always have great support for .NET. That's the foundation with which we had built SQL Server on. But as our customer profile sort of grows, where we have customers who are using Java, Node, PHP, like I mentioned, we're going to have first-class support for all these languages when they want to program against Azure SQL Database, right? And the same thing with the deep integration that we've done with R and Python, and I'll talk about that in a second, where you want to build intelligence right inside on the data, inside the database without actually moving the data. We're going to enable that as well. And finally, again, I sort of spoke about the telemetry data that we're collecting, every day, 700 terabytes of it, right? And one of the things we've sort of created based on that data is this ability to track when a connection that's coming into a database is essentially a malicious one. It's actually attempting to do some sort of a SQL injection attack. And we GA'd this feature called threat detection very recently, which is extremely popular with some of our customers in the financial and the healthcare sectors, where effectively they're saying, look, I have my database in the cloud, but it's very secure against malicious attacks because of this feature, which is, again, based on a lot of telemetry data that we're collecting around access patterns and such. And all the other features, always encrypted, SQL 16, that was a pretty amazing feature, which sort of keeps your data encrypted throughout its life cycle. Row-level security, transparent data encryption, using your keys with Azure Key Vault. All that goodness of SQL Engine is always available, right? So this is the way in which these are the pillars that we believe are the foundation of the relational database PaaS service based on our perspective that we've built by talking to developers on the challenges that they feel when they run into building global scale relational applications. Right. Now, what's sort of up and coming in terms of the feature set before we get into the customer stories? On the security side, advanced threat detection, we recently GA'd that. We're going to have transparent data encryption with AKV integration, so you can use the keys and get the keys stored in the AKV account that you have, since essentially it's a way in which you can manage your own keys. Encryption is going to be on by default. You can always turn it off. I mean, we've done performance and scale measurements, and we see a hit about somewhere between 5 and 7%. So if that's a big deal for you, you can always turn it off. But more and more when we speak to our customers, they actually love the ability that by default, the databases are encrypted out of the box, right? On the intelligence side of the pillar, the big news is R and Python. With R got added to SQL Server 2016, and Python is coming with SQL Server 2017. And why is Python so awesome? Because when you think about deep learning, which is a huge part of when we say AI on data, most of the deep learning libraries, so C and TK from Microsoft, that came out of our MSR and Bing work, TensorFlow from Google, Caffe from Facebook, by default, they come with Python bindings. So if you're able to host Python code natively in the extensibility architecture that we did with SQL 16, then you get all these benefits. The good news is, sometime in early fall, we are actively working on this. We're going to enable that on Azure SQL Database as well, right? So that's great. We're very excited about it. Graph processing is coming with SQL Server 2017. We released it. It's available in preview form today. And for a lot of applications that have very tight and complicated relationships, getting insights, it's not easy. When you sort of have a foreign key relationship, it's sort of more one-to-many. And when you sort of get into defining a lot of many-to-many relationships, it's challenging. It's possible to do that, but it gets very complicated, and getting the perf and scale right is not easy. So with Graph, we are fixing that, and again, super excited. Adaptive query processing, again, this is a cool new innovation. I mean, you all know we have a cost-based optimizer, so it makes a lot of decisions at the time the query plan gets generated. But sometimes it's not accurate, right? There are certain constants that we have based on which it tends to make wrong choices. And this is the first time we're sort of making changes where the query processor is going to learn based on an action, right? It's going to learn whether the choice it made for things like memory grants, as an example, was the wrong one. And for very, very long-running queries, you can imagine if certain queries run for 14, 15 hours, then it's able to adapt and make changes. And some of the gains we have seen are actually incredible. Queries that were taking 12 hours now finishing up in like 2 or 3 because of that decision point. Now, obviously, if it's a very short query, the amount of time it takes for it to sort of figure out whether it made a mistake, it's almost not cost-effective. So it sort of works with long-running queries, but we're seeing great gains with that. And it's just the beginning. I think this is a key innovation which, in the long run, you can imagine we're going to make the query optimizer a lot more intelligent than what it is today. And automatic performance tuning, this is a feature that's available in Azure SQL Database today, where we again learn from your access patterns. We learn from your queries that you issue based on the intelligence that we're storing inside the query data store. And based on that, we can give recommendations around things like missing indexes, or if you have extra indexes, if your parameterized queries are not constructed properly. And we're going to keep pushing the boundaries of this in a big way. So extremely excited about that. In terms of continuity and cost, automatic disaster recovery, this is a thing which it's already created for you, where you can set up a disaster recovery relationship, and the system, like the platform, can decide if the failover needs to happen. So it doesn't wait for a manual failover from your application standpoint. Next generation data sync. Data sync is probably the service that's been in preview for the longest time in the history of Azure, maybe the history of the world. We're finally taking it seriously. No, I'm just kidding. Yes, we are. But we're going to work on that, and there's a lot of very cool customer scenarios that are built around it. Long-term data retention, we have, you can save up to 35 days of data backup data today in Azure. But we have lots of customer requests where they want the backup data to go on for several years, right, because of compliance requirements and such. So we are bringing the ability to do that in Azure SQL Database. And our plan here is to open up the backup APIs as well in the limit. So all the tooling that works today, if you have third-party tooling that you're using for backup and such, that will start working. We launched Premium RS. This was, again, based on feedback that we got from the developer community saying, hey, look, I want to use the Premium database for dev and test, but it's too expensive, right? So we basically want to sort of use, and basic and standard don't work because the perf characteristics are very different. So in the CI/CD pipeline, we want to use this, but it's not a production database, and we're getting some really good feedback around that. So the number of replicas are fewer, so the availability is lower, but for dev and test, it's great. We're increasing the bursting of every database in standard pools. So today, we limit the amount. Once you sort of have a standard pool of databases, we limit the amount you can burst on every single database. We are increasing that to the max DTU of the pool, which is great, right? It's extremely cost effective. And then we, again, are working on constantly increasing the density of pools. So there's a lot of very good value that's coming from a developer standpoint, and again, super excited about that. So for the first story, let me invite Bob on stage. So ASOS is, their goal essentially is for 20-somethings, this is what they claim, that they want to be the #1 fashion retailer of the world, right? And 3 years ago, they basically went through the journey of almost rethinking, how their platforms, e-commerce platforms, going to look. And they went through a pretty amazing transformation. And Bob was at the tip of the spear, leading the technical direction. So let me invite him to come and share a story. Please welcome Bob.
Thanks. Good afternoon, everyone. My name's Bob Strudwick. I'm a Chief Technology Officer at ASOS.com. And Rowan asked me to come and spend 10 minutes or so talking to you about our adoption of SQL Azure, our thinking, and some of the lessons learned that we've learned along the way. So, in adopting SQL Azure, let's start with this. What were we after? We were after these things, sort of beyond stability, cost effectiveness, performance, and all of that. We wanted on-demand database resources. We wanted a solution that fitted our DevOps tooling and strategy. We wanted to remove ourselves from the business of database backups and those things that don't per se bring competitive advantage. And we wanted to drive a greater degree of software engineering autonomy into the data tier. But first, for those of you who have heard of Azure and SQL Azure, but maybe not too familiar with ASOS, here's us by numbers. In the simplest of terms, we're a pure play e-commerce operation in the apparel market. And by way of scale, we're talking $2 billion annual turnover, 85,000 products, 14 million active customers, 8 million active native mobile users, 100 million page requests a day. That type of scale. And in terms of our technology stack, our consumer-facing services, what we call the digital domain, here we're using primarily a Microsoft technology. And for those of you who came to our talk yesterday, you'll know that this software has recently been replatformed to a Microservice architecture in Azure, primarily cloud-based services backed with independent SQL Azure databases. And that replatforming program is really the background of my 10 minutes of thoughts today. So let's sort of get into this a little. Starting with the on-demand goal. ASOS has been growing by 25–30% year on year all the time I've been involved with it, which is 6 or 7 years now. And we're expecting to do the same this year. So clearly the sort of traditional model of capacity planning was a problem for us. We were constantly buying new hardware, the fastest servers with the fastest storage to keep up with demand. And compounding that problem was the peaky nature of the retail cycle. In the weeks before and after Black Friday, we take 10% of our yearly revenue. Orders on Black Friday 2016 were 100% up from the year before. And on that day and in that week, we need resources that we simply don't need all the time, every day. So capacity planning was a problem. But where that on-premise model sort of really fell over for us was in the way that it impeded teams' abilities to develop, test, and support their own code with a DevOps mindset. So how did the adoption of SQL Azure sort of help us address this? Well, I guess the first thing to sort of cover off is the tool integration. So over the last 5 years, as part of an enterprise-wide DevOps adoption strategy, we established the principle that the database projects held under source control would be our single source of truth. And we invested heavily in managing our database tier through Visual Studio, through SQL Server data tools. And so it's really important to us that SQL Azure sort of aligned to this principle, that we could carry on managing, developing, and deploying to SQL Azure with our existing tooling. So it's really great that all aspects of SQL Azure can be defined programmatically through the RESTful APIs, through T-SQL. And we're really pleased to see sort of tool features being delivered bi-monthly to ensure that they keep pace with the capabilities being added to SQL Azure. But beyond that, by automating the stand-up of development and test environments through our CI/CD framework, we get to sort of focus more energy on the sort of functional and load testing, identifying bottlenecks, resolving potential design issues before we go to production. And because in SQL Azure, these test instances are transitory, we get to turn up the knob to 11 for our testing. So in the days when we relied on the on-premise model, like many organizations, I suppose, it was viable to have one set of realistic test kit, but not multiple sets. And invariably, as the production kit increased in capacity, the test kit would lag behind. And the simple truth is that investing in test kit for small windows of time is difficult to justify. So in the cloud model, we get to scale test instances to 2x, 3x production volumes to make sure they can handle whatever's thrown at them. Free of the constraints of tying up capital in test hardware. With SQL Azure, you can do that. You can do it multiple times over, and then you can turn it off or dial it back when you're done. So sort of expanding on this theme a little, there's a few points to be made about focusing resources away from the sort of commodity compute function and how that sort of the move to platform as a service manifests itself. And perhaps for the first time sort of talk about the trade-offs of life in the cloud. Clearly our aim is that we don't have database engineers managing our SQL Azure platform, that we have no complex SAN infrastructure to manage, no multiple data center contracts to arrange, that our data engineers aren't spending their time configuring replication or checking backups. We want them doing what they want to do, which is implementing functionality that the business wants and making those systems scale better. And that's achievable, but it comes as a package, and it's worthwhile exploring at this time the degree to which SQL Azure sort of introduces an interesting new discipline. And I guess the first difference is that in the on-premise world, you have ways of compensating for bad database design. You can throw silicon at a problem. You can increase memory. You can add solid-state PCI cards and all of that. And those things allow you to hide a multitude of bad practices. Well, with SQL Azure, you don't really have that option anymore. And those constraints mean that your teams aren't able to sweep technical debt under the carpet, but they're forced to address it. And this played out loads of times last year. Stock service, bag service, order processes all come to mind where we would isolate poor code in performance testing and rework it. And as this is the cloud, the second difference is that you're really forced to design and test for failure. By the same token that we're not involved in the commodity compute functions, the server upgrades and the security patches and all that, you have no control over them. And because they're happening outside of your control, they manifest themselves in a greater degree of transitory failure than you would normally expect. And we did loads of this type of testing last year, modeling what would happen if SQL Azure in EU North went for a smoke break, or what would happen if Azure Redis failed and it sort of fell to SQL Azure to take the load for a while. Clearly, the on-demand capability is sort of one part of being able to accommodate this discipline, to make the platform as a service model work, as is automation of the deployment of the data tier, as is the simplicity with which high availability and geo-replication is configured. But the trade-off exists. And it's about focusing the database resources on developing good, fault-tolerant database design within a more constrained platform as a service context. And lastly, let's talk about the use of SQL Azure in the context of a microservice architecture. So in our talk yesterday, we spoke at length about managing the process of emergent design, of accelerating the point at which we sort of realized the promise of autonomous teams working on independently deployable groups of capability. Well, how does that play out in the world of SQL Azure? I guess you start with the idea that it's just SQL development. Our database engineers use familiar diagnostic tooling for problem triage and resolution. It's the same query plans to show execution. It's the same DMVs to show contention. It's the same management studio to run queries and all that. But what we experienced through last year is that the microservice approach sort of allows us to handle more technical diversions in the data tier. So just by being in SQL Azure, new features are introduced automatically, and they're available to be used as they're needed. And because the microservice approach frees the individual teams to use them, and it frees them to use them without worrying so much about everybody else. Now, if you contrast that with the world before replatforming, our legacy databases were consolidated on some large tin for economies of scale. With 35 software engineering teams and a bunch of deadlines, upgrade is a major undertaking, the coordination of, and it becomes a major impediment to the adoption of new technology. Now, contrast that with life in the microservice world, and there's loads of examples of this, but to pick one to illustrate the point, sometime around the new year, we had an issue in production with our price service, caused by excessive contention at the data tier. Now, the data engineers on the price service sort of concluded that they needed to use memory-optimized features to resolve the issue. Well, as SQL Azure has feature parity with the latest SQL Server Enterprise version, the latest on-prem version, so without doing anything at all, we had the entire hackathon feature set available to us. There was no upgrade required, no sort of coordination, no additional configuration. We just made the minor changes needed to enable their use. We redeployed, and it just worked. And clearly that's good, but it's sort of worthwhile saying at this point that as in the previous point, there's a trade-off to be made. So in this context, the same mechanism that allows sort of new features to arrive unbidden in SQL Azure, that same mechanism allows bugs for those features and fixes to those bugs, to those features to arrive unbidden too. And that sort of limits your ability to work around them. So for example, in our original bag service design, we used both sharding and geo-replication. And what we discovered was that there was a bug in Shard Map Manager, which meant that the replicated version of the shard map pointed to the wrong shard. And so we thought about working around it, but in the end, you figure some other way of doing it and you move on. So I guess in summary then, and our transition to SQL Azure has been really successful. We sort of mostly understood the trade-offs. We wanted on-demand data-based resources, and we have it. We wanted a solution that fitted our DevOps tooling and strategy, and we have it. We wanted to remove ourselves from the business of database backups and all that, and we have. And we wanted a greater degree of software engineering autonomy at the data tier, and we have it. But there's been challenges. The trade-off thing is real, but for us it's worked. And the CAT team and the product labs have been there for us when we've needed them, and that's been great. So I'm going to hand you back to Rowan now. I hope that you thought that was useful and that you enjoy the rest of the conference.
Thank you, Bob. And Bob gave a much more detailed talk yesterday, so if you guys want to know, have questions about further detail, I encourage you to go watch that. Now, one of the things is, to go through a transformation like this, we think there are 4 aspects that are very, very critical. The first thing is just deciding to bet on the cloud for your infrastructure. I mean, if you want to be a globally present business, if you want your app to scale globally, trying to build this out worldwide is just almost an impractical thing to do. Right? So that's, from an infrastructure standpoint, you have to embrace the cloud. The next part is essentially making your application cloud aware as well, which is, so using features like geo-replication to do read scale, where if you have some sort of reporting on your app, and you want to sort of spread that across worldwide. And we have customers who are doing this today, where their primary, let's say, is in Europe and a bunch of secondaries all over the world, including things like Australia, Japan. And when their customers are actually running reporting queries, it's sort of going to the replica that's closest to where they are. So that's the whole nature of getting cloud to their applications. Again, and finally, from a transformation standpoint, when you get into rich application building, there's differentiating with business analytics. There's a lot of telemetry data that's coming out, within SQL Azure that, we sort of can share out broadly with applications that can be used. And finally, using features like Graph, R, and Python inbuilt to the data to build intelligent apps. So for the first thing around just sort of moving or modernizing your data platform to the cloud, one of the things that I'm very excited to announce is this notion of Azure SQL Database Managed Instance. It's a new deployment option or SKU that we're going to make available. It's available in private preview today. You can sort of work with us and sign up. And the idea essentially is to lift and shift, migrate, expand your current footprint that you have to have worldwide without doing any application redesign. Like features like SQL Agent, 3-part name, CLR, transactional replication, CDC, service buffer, et cetera. Some of these that don't work in the database scope model because these are more instance spanning features in SQL Server, those are going to be available. But the beauty of the managed instances, you get fully functional SQL Server instance without losing the value of the PaaS service. So the PaaS fabric that we have that essentially does things like, HA, DR, manages your backups, point-in-time restores, security, replication. I mean, the intelligence that we spoke about, that fabric essentially is the same one that's underlying the managed instance. So security and Azure VNet isolation, you get that. And you can move your entire fleet of databases at once. So it's not just a per database move. It makes it really, really easy. And along with this, one of the things that we are building is the database migration service, which essentially, tries to automate, or the goal for us is to automate all the learnings that we have from our on-prem migrations. Again, this is not just from SQL Server to a newer version of SQL Server with Oracle, Sybase, et cetera, to SQL Server as well. The whole thing around the assessment phase, the schema migration, data migration, setting up the link, having the primary, secondary configuration, getting enough trust, and then finally failing over. We have our internal applications like SharePoint and Dynamics CRM that are built. They essentially have their hosted SQL servers that they are replacing with SQL Azure. They're going through this journey, and we are learning a ton with them. And that all the learnings that we're getting is sort of being built into the service. So it's a great again, it's a great feature. So to share the journey of such a transformation where, let me invite Eric Fleischman, who's the chief architect of DocuSign, to talk about what they're going through as they're thinking about expanding their business. Eric?
Thanks a lot for having us. So DocuSign is a multi-continent deployed platform service today. We run on SQL Server for our OLTP environment, and if you were to look at our existing footprint of SQL, what you'd find is a partition system running across 6 data centers on a couple of different continents, with entirely flash storage under the hood. And what this has delivered for us using originally 2012 and now 2014 and in partnership with the SQL team 2016 is incredibly fast performance at scale. We push per partition slice about 50,000 transactions per second through our SQL rig, and we do it with median and mode stored procedure execution time as measured on the front-end web server at under a millisecond. Our users care a ton about perf. They want this system to be rocket fast. They also want it to be incredibly reliable. We run a 24/7 operation, no structured downtime of any sort, and we're running it greater than 4.5 nines over the last 18 months. So we want incredible speed at scale reliably. And we've achieved that. We do that today with SQL Server using 2012, 2014, and 2016, but really 2016 where we did the partnership work with the SQL team. But it isn't everything to us. There are some number of things using our existing stack, there are some number of things that we're constrained with in what we can do today. One of the biggest constraints we have is a pragmatic reality of deploying to more and more continents as we go. We have customers that want DocuSign in more countries. Now, we could go stand up lots of data centers, but pragmatic realities set in. We don't want to operate lots and lots of data centers in lots and lots of countries. We operate the data centers we have, and we get that that's part of what we do, but we want to go faster. We want to deploy DocuSign to more and more places for more and more customers. But we don't want to sacrifice what we've done to date. And unlike the previous story you heard, we don't have, maybe this is our bug, but we don't have an appetite to do a massive replatforming effort. We don't want to go rewrite large amounts of code to avoid surface areas of the SQL product. And so we took a run at this. We took a run at doing this on Azure maybe 9 or 12 months ago using 2 different approaches. We used SQL in IaaS mode, so just lighting up SQL inside of Azure VMs. And we also took a run at using the SQL PaaS offering, SQL Azure. And both offered us a bunch of stuff. They got us onto Azure, but there were sacrifices. There were elements of the stack that either we lost functionality on the SQL Azure side, or we didn't get the performance and scale that we wanted on the infrastructure as a service side. So for us, managed instances are really the enabler that can get us onto public cloud. We can lift our existing software stack, deploy it into new continents as managed instances come to those countries, starting in Canada for us. We can light up a new instance of DocuSign, offer that to our customers. We get NVMe storage underneath those managed instances, and we don't have to do this massive replatforming effort that, as I mentioned before, we just don't have the appetite to do. We want to take this thing, point it at a new instance, and run it. But we also want additional cloud capability while we do that. We want to let the SQL engineering team, quite frankly, do what they do and help us optimize our rig, getting the software upgrade cadence, the management help, the capability to learn adaptively from our workload and make the product better. All of these things that the SQL team is super well able to do on our behalf, we want their help, quite frankly, in running this rig. And so for us, managed instances really found that sweet spot. It let us deploy into cloud rapidly without the massive replatforming effort, without compromising the performance, scale, and reliability. So over the next bunch of months, there we go, over the next bunch of months, we're going to deploy into a managed instance world. We have some test instances that we've been playing with, thanks to help from the SQL team. We were able to fire up the rig almost instantaneously. There were 1 or 2 teeny little strategic changes that we had to make, done in under a day of effort. And up and running was our platform on a managed instance world. Despite it being a 10-year-old code base, millions of lines of code, hundreds of engineers that have contributed to it using a variety of surface areas of the SQL 2012, 2014, and 2016 product, it just ran. It just got up and running. And so as the team delivers, I think there's a picture here, as they deliver managed instances for us, we can actually get all of the topology that we're looking for running in country for our users. As I said before, starting in Canada and hopefully growing to more and more countries as both of us build and operate this platform with great reliability over time. Is there anything else you'd add, Rohan?
Oh, no, no, actually, I think this is a fantastic story. And one of the things is when we were in the final leg of building SQL Server 2016, I'd almost get a heart attack every time I used to get an email from Eric, because he's like, man, this doesn't work and that doesn't work. So, it's sort of been a great partnership. And, I really want to thank Eric and the DocuSign team. I think they've been fantastic partners for us. Very excited about the managed instance work. I think with the managed instance, like Eric said, we've essentially closed the gap that complicated applications like what DocuSign has on-prem, the blockers that they had to move to Azure. By the way, even today, close to 55% of the Microsoft IT applications that are built on SQL Server are able to move to SQL Azure without any changes, right? It's when the instance level capabilities sort of come in, like the three-part names, the requirement for SQL agent, etc., which the database scope model wasn't designed for, get addressed by the managed instance. So we're very excited about this. With this, there should be no excuse anymore. You should be able to migrate and expand, your business, sort of, modernizing your applications to the cloud platform and spread it globally with no problem. So thank you so much, Eric. Really appreciate your help. All right, so that hopefully, gave you two very different perspectives of, like customers at ASOS sort of going and doing a complete rewrite. And again, they've been, as they've transformed their application, it's been great learnings for SQL Azure as we've built up our new database scope model for the newer apps. So that's sort of been a great learning. And again, we hope the same thing's going to happen as we go through the journey for managed instance. And please reach out to us if this is something that you're interested in learning more about. All right, so sort of getting in for the final part of the talk, let's sort of look at what an important customer of ours, Chorus, it's a car company based in China, has done. Again, this is a global company. They manufacture the cars, and right now I think they sell it in Europe and Asia. And their theme was, they basically said, hey, we don't want to build just another car company. The world doesn't need that. Their premise or their distinct value prop is, we basically want to build a car company that integrates very well with the lifestyle of the person driving the car, right? And it's essentially a connected car scenario, so it's an IoT app, getting to more specifics. And what we're going to walk through, Perry, you want to come up on stage and set up while what we're going to walk through, Perry and I, is what an application experience, what a rich application experience sort of looks like, in a scenario like what can we expect, and how that can be enabled both from a richness standpoint using features, intelligent features that we have inside Azure SQL Database based on the SQL engine, and create a globally consistent experience by using the geo-replication feature and replicating the database in all the areas where your business exists worldwide. All right, so this is the one, right? All right, so let me actually show you.
Let me log in.
Oh, do you want to? Thank you. While Perry logs in, let me actually show you what, when they say we want to build an application with rich immersive experiences, what that looks like. Right, so here what you see is the dashboard of the car. So when I'm sitting in the car, this is the dashboard, and you see there is something that's flashing, right? And it sort of attracts attention, so I go click on that, and it's basically a health check, which essentially tells me in my car that there's a bunch of maintenance that needs to happen, and I need to go schedule my 10,000-mile service. Now this happens, you have lots of smart cars these days which effectively, have been sort of doing this for a while. Now the interesting thing in the experience that they're building is the ability to basically go schedule the service from within the app that's stored inside your dashboard. Right? And this is key, which is the application has enough information of where your service station is, because usually what would you do? You get this indication, pick up a phone, at some point you might forget it multiple times. So the richness essentially comes from the fact that the deep integration of the experience of scheduling the service right at the time that you get the signal. Right? So you don't postpone it, and then you don't, again, 2 weeks later, that thing comes up, and it's something that you stress about, right? And that's just an example of the richness that they created. Now, the other interesting part is the same experience exists on the phone. So let me click on the app. It's again the same thing. So it's the experience that you saw inside the dashboard of the car essentially is the same one that they've exported as an application built on the phone, right? I can basically go and say, submit, and there's a workflow that happens where my service essentially goes ahead and gets scheduled. But this is just an example of the richness and the deep integration. And I'll invite Perry to talk about how this was built on SQLDB.
Hey, Rohan, thanks. So let me, before we dive into the SSMS and see how the database is actually architected, I wanted to spend a few minutes to go over a high-level architecture of the whole app. So let me switch to the next one. So while there are multiple technologies and building blocks that we can use to build that IoT connected car, for this specific version, we wanted to use Azure SQL Database in the center so we can provide a highly scalable, performant, and easy to build and architect solution. So our first goal with this application was we wanted to provide high throughput, low latency data ingestion. And for that, we're going to use in-memory OLTP database with memory optimized tables, natively compiled store procedures, and memory optimized TVP. We chose in-memory OLTP because there is no locking and latching technologies, meaning that concurrent executing transactions are not blocking each other. So this makes in-memory OLTP perfect for this data ingestion goal that we have. To manage the memory footprint for that, we're going to offload the historical values of the telemetry coming in to a temporal table, meaning that we're going to keep the current values in a memory optimized table and the history in a temporal table, which we're going to see slowly. So for the second goal, while we're ingesting all those telemetry, we want to be able to provide real-time analytics on the same schema. So for that, we're going to use a column store index, which is perfect for great performance, but also data compression as well. So you get great performance, but also your size goes down. So it's perfect for real-time analytics. Third goal is we want to be able to create and query highly connected data. As Rohan mentioned, the new SQL Server extensions, built-in SQL Server is perfect for that. So having your graph data and the relational data under the same server is perfect. Goal number 4, we want to be able to have application and reporting consuming all this data, of course. And finally, we want this to be geo-aware application. For the traveling user, we want to provide a consistent experience regardless of the region that they're in. So again, low latency, high performance application regardless of the geo that the user is in. So with that, let me switch to the back end and show you guys. Where is it? Up. Demo. So here we're, to simulate the data ingestion, we are monitoring hundreds of thousands of events from those IoT connected cars coming in. Sensors like brakes, ABS, those kind of things, they're coming in into a single connected car Azure SQL database. And a single table called events. So let's see how that table looks like. So if you remember from the goals, this is a memory optimized table. For the ones of you that haven't used in memory optimized table, the syntax is exactly the same. All you have to do is pretty much tell it that this is a memory optimized table and that you want durability and schema, meaning that the data will be there if there is if SQL Server goes down. Not that it's happened, but in order to manage the memory footprint, if you remember, otherwise, we're going to be running out of memory. We want to offload somewhere. So that's why this is a temporal memory optimized table. And in order to just tell it that, you just say system versioning on. So imagine all those 1,000 events coming into this single table. If you remember, the second goal was, while the ingestion is happening, we want to be able to provide real-time analytics. And for that, we have created a cluster column store index on the temporal table, which is the event history. So now what I want to show you is, I'm going to run a couple of quick queries, one against the memory optimized table, which is the events. Just to demonstrate that while this is happening, there is no performance degradation. My ingestion is still coming in high, and I'm able to query those results real time. Same stands for the temporal table. So this is an aggregate query that goes against the temporal table, and hopefully we'll be able to get the 10,000 maintenance event that Rohan mentioned. If it can zoom. Yep.
Correct, yeah.
So there you have it. So very cool stuff. All you needed to do is one memory optimized table, which is a temporal, to ingest the data and pretty much run analytical queries, the whole 8-step scenario on top of the table. So easy to build, very performant.
That's great. So ingestion was fast.
Yep.
And you were sort of storing this in the column store, and that didn't land up impacting the performance of your memory OLTP table, which is fantastic.
Yep.
All right, now let's go and sort of look at a different experience. If you sort of change this. Now, in the same app, there is a little bit of a view just around how am I performing as a driver, right? And again, the experience that the car company is after is essentially using the app, can we sort of drive the right behavior and almost sort of create a little bit of a competitive spirit with your, the social circle that you have amongst your friends. So in this case, as an example, I have notifications. It essentially tells, there are certain service deals, and there's a performance rating that it gives me based on my the driving history, and there's a specific rank, and I can essentially go, take a look at the social ranking tables, which basically compares the way my driving is relative to some of my friends. And over here, I see Shreya has a much better driving history than I do. And so I want to understand what is it that she's doing that's helping her sort of rank higher than I am. And again, the concept over here, again, imagine all these experiences in the car, the experiences on the phone, and you're learning how to become a good driver, a better driver, just based on the signals that they're collecting from the car and showing that to you. Right? So again, it's more than just the car, like I said. They're using this whole IoT scenario to essentially give you these rich experiences that improve your driving. Right? Now I can sort of click on that and essentially do a comparison of characteristics around, how do I do lane change detection, right? Like at the efficiency with which I'm driving, am I stopping and starting very quickly? Am I sort of accelerating, the braking habits, etc., which determine the impact on the car, the risk of an accident, and the fuel usage. Right? So all the social experience, again, needs the part of the backend database, which allows you to generate relationships and intelligence. And so let's take a look at how that happens.
Absolutely. So let me switch back to the previous view and take you back again to SSMS. This is where we left off. First, I'm going to show you how this view was powered. And of course, as many of you have guessed, this is the new SQL graph capabilities built into SQL Server. Because graph capabilities are built into SQL Server, that means that all the existing features of SQL Server just work. The same storage engine, the same QP, same everything. Same stands for the tooling. SSMS just work. Tools like import, export, backup, and restore, they just work. So in the latest version of SSMS, I'm going to show you here the new graph node. Here there is a latency. I lost the mouse. Nice. 1 second, I think the mouse is dying.
The graph needs to scale for the mouse speed.
Yeah. Oh my God.
You might want to get out of the...
Yeah. Okay, so this is the new graph node. For this example, we're using 3 nodes and 3 edges. The way to go from a node to another node is through an edge. For this application, you see that auto is a node, person is a node, drive score is another node, and then we have 3 edges, has score, is friend of, and owns auto. So if I switch back to the graph here, from the same SQL engine, I'm going to be able to see give me all Rohan's friends that drive the same car as Rohan, and then their scores. So you see here, this is the same SQL Server that you have used so far, with the only difference that we have added a new match clause. And I want to take 1 second to walk you through this. The way to read it is you start from the middle, saying, give me all the persons that own a car, going to the left, that also are friends with another person that owns a car, with the same make and model, and this is convertible two-door. So executing that and then zooming in, this is the same view that we saw from the application. So very fast, with the SQL that we know, nothing special there, we are able to query highly connected data from inside SQL Server.
Hey, so this is great, Perry, but I was sort of wondering, like, I land up traveling a lot in my job, and one of the biggest challenges I see is, when I'm in Seattle and I open up my phone, I get all these rich experiences with the apps and everything, and whenever I land in a different country or a different, definitely in a different country, the experience sort of suddenly degrades and it's huge, very painful. Like, so how do you solve that problem with SQL Azure?
So great question, and the way that we address that, and this is actually the way that the actual Chorus application does that, is it creates geosecondary readable replicas across the different regions, meaning that the app is smart enough, as you earlier mentioned, to understand the region that the user is in and pick the closest database to serve those read queries. And it's super easy to do in SQL Server. You can do it through the portal with a couple of clicks, or you can do it through alter database tsql command.
So that's it, that one statement just creates, I'm able to create replicas anywhere in the world.
Yep.
Where Azure regions. Got it.
Super awesome.
All right. Well, thank you so much, Perry. Thank you. I think that was great. Again, all this code that we have for this application is already on GitHub, and you will share the links if you guys want to go try it out. Like I said, this is not just something that we made up. There is, Chorus has sort of built an application of this on SQL Azure. They're using this for their connected car scenario, and it's great. And just in terms of wrapping up, I hope this session sort of gave you a sense of, like the challenges that that you run into as a developer when you sort of build a global scale relational app, right? And as as companies and ISVs are looking into transforming their applications to the cloud, modernizing their applications to the cloud, there are two scenarios which both of us we saw where there's appetite to sort of almost rewrite the app, just like ASOS did, where they fundamentally changed their architecture to sort of be completely modern. SQL Azure SQL Database is a great place to sort of come and start that to build your relational app. And even for the scenario where, like what Eric was explaining with DocuSign, where they've already invested in building a world-class application platform on-prem, right? And they really just want to sort of use the cloud as a way to sort of expand and modernize. We've made that simple with the introduction of managed instance. Like I said, a lot of your applications can move today. You don't have to wait for the managed instance. But for the really complex applications which require the instance level capability, we are sort of closing that gap with Azure SQL Database as well. So very excited. And then finally, all the new capabilities that we are adding to build intelligent applications, right? Whether it be graph, whether it be running R scripts inside SQL Server, creating and operationalizing machine learning models for scoring. Python is coming in as a part of SQL 17. That's going to be enabled in Azure SQL Database as well, which will get you to build deep learning applications. So it's not just about modernizing your app in terms of leveraging the cloud infrastructure for performance and global scale, but also building rich experiences like Chorus did in terms of deeply engaging with their customer base. And finally, just the platform itself. It's not that we just give these as features for the applications to use. In Azure SQL Database, we are betting on the platform we are building. So the machine learning models that you can create in SQL Server or Azure SQL Database when we have that feature in fall is something we are using ourselves, right, on the data that we are storing in QDS, on the telemetry data that we are collecting to create machine learning models to do threat detection, to improve your query performance, to detect regressions, and accurately pinpoint whether it was a change that you made or a change that we made in the system, and almost correct that in real time wherever possible. It's a great platform. We are building this both to enable seamless transitions to the cloud as you modernize and to build intelligent apps for the future for the next 15 to 30 years. So thank you so much, and we can't wait to see what you're going to build on the Azure SQL Database.